Hi, and welcome to video 4 for section 3.7. This is the fourth of 5 videos. So, we've learned a bunch about rational functions, about transformations, about the asymptotes. Now we're going to kind of put it all together to sketch graphs of rational functions. So we have a few steps. First thing, we're going to factor the numerator and the denominator. Once we do that, we're going to find the x-intercepts and y-intercepts. We're then going to find vertical asymptotes. Fourth, find our horizontal asymptotes. And then finally, once we have all that, then we'll go ahead and sketch it. So, let's look at an example. So let's say we want to graph r of x is equal to 2x squared plus 7x minus 4 all over x squared plus x minus 2. And then once we have that, we want to state the domain and range. So, step 1, factor numerator and denominator. When we do that, we end up with 2x minus 1 and x plus 4 in the numerator. And in the denominator, we have x plus 2 and x minus 1. So we're just factoring them separately, so we rewrite the polynomial, the rational function as the factored polynomial. So step 2, now we want to find our x and y intercepts. So with our y-intercept, we do what? We set x equal to 0. So y-intercept, we set x equals 0. And now that we have this thing factored, or maybe it's easier just to go back to the original in this case, if x is 0, then we get what? 0, 0, minus 4 in the numerator. And then 0 plus 0 minus 2 in the denominator. Negative 4 divided by negative 2 is positive 2. So our y-intercept is at 0, 2. Our x-intercept, well, we do what? We set y, which is the entire function, equal to 0. So if I do that, if I was to set this guy equal to 0, well, what's the first thing I do? I multiply both sides by the denominator, which means all I really have left, so if I multiply this side by the denominator, it cancels out. So I have 2x minus 1, x plus 4. And this side, when I multiply it by the denominator, it's still just 0. So really, for my x-intercepts with these rational functions, I'm just setting the numerator equal to 0. So 2x minus 1, x plus 4 is 0. And now I use my 0 property rule. That's why we wanted to factor it. So we get 2x minus 1 is 0. So 2x is 1, x is 1/2. And x plus 4 is 0, which means x equals negative 4. So I have 2 x-intercepts. I have 1 y-intercept. Step 3, our vertical asymptotes. So vertical asymptotes are what? Vertical asymptotes are when the denominator is 0, and that's why we factored this to make these couple steps a little easier. So when the denominator is 0, I have x plus 2 times x minus 1 is 0. Again, use 0 property rule. So x plus 2 is 0. X is negative 2. So So these are our vertical asymptotes. And then x minus 1 is 0, so x equals positive 1. So I have two vertical asymptotes here. And then 4, find my horizontal asymptotes. So horizontal asymptotes, we're worried about what? We're worried about the degrees of the polynomials. So if I go back to the original, this is x squared, this is x squared. So if they're equal, what do? I just take the ratio of their coefficients. So that means my horizontal asymptote is at y equal 2 over 1, which is saying y equals positive 2. So I have a horizontal line at y equals 2. So now, I'm going to sketch this. So let me make a quick point too. If you look in the book, or maybe your instructor will have you find end behaviors in step 3. So when we find those vertical asymptotes, what's happening to the graph? Because remember, that's what we were talking about originally, is like we're concerned what happens as those graphs get towards the asymptote. So you can do that, but based on what we know about rational functions now and what their graphs look like, we can kind of get away from that step because we've got a few different points. So we know that depending where that point follows, what the graph should look like anyhow, and we can kind of just sketch it from that point. So I'll show you what I mean here. So step 5 is we're going to sketch this guy. All right, so step 2, we found our intercepts. So our y-intercept is when x is 0 and y is positive 2. So that's right there. Our x-intercepts is that x equals 1/2 and x equals negative 4. So way over here. Step 3 and 4 were our asymptotes. So our vertical asymptote is that x equals negative 2 and x equals positive 1. And we also have our horizontal at y equals 2. So, because I have some of these points already, I know that a rational, if it's just 1 over x, it looks like what? It looks like this, and it looks like that. And what do we notice about the end behavior as we get close to these vertical asymptotes? Well, if this one's going to positive infinity, this one's going to negative infinity. And that's on the far end pieces. So for here, because I already know I have a couple points, this one here, I have to go through this point. That's my x-intercept. So I already know that this graph is going to have that sort of L shape or cup shape in this piece, which means the opposite end up over here is going to be the other portion of this. So that means this graph goes up here. It doesn't have an x or a y-intercept, so I didn't have any points in that part of the graph, but I know because this one is in lower left, the matching piece has to go in the upper right. But what about this middle section? I've got a y-intercept, I've got an x-intercept. Well, just like with my base graph, when I jump from one side of the asymptote to the other, the graph is going in the opposite direction. So that means, because I'm going towards positive infinity here, the graph has to end up going towards negative infinity down here. And similarly, this one's going down towards negative infinity, so on the opposite side of this asymptote, I have to go to positive infinity. And then I just need to connect these two lines going through my intercept. So this is coming down here and then going through that line. So now I know what you're saying. Wait, you got the horizontal asymptote. How come you just went right through it? The horizontal asymptote is telling us the end behavior at the very left and very right side of the graph. So if I have multiple sections, the horizontal asymptote isn't applying to that. So these values all still count, including my y-intercept. So this value still hit. It's just that on the far right, I'll never hit +3, and on the far left, I would never hit +3. So that horizontal asymptote's only sort of protecting the ends of the graph. In the middle of the graph, it's okay if you go through it. And again, the property is if I'm going towards negative on one side of the asymptote, I go to the other side, it's going to be positive. If I'm going towards negative, it's going towards positive. And the opposite corners always have the base function of what the rational function looks like. So that's it for that guy. That's graphing a rather complex rational function. Come on back and we're going to look at the last part of this section, which is our slant asymptote. So if we don't have a horizontal asymptote at either 0 or some other value of y, how do we handle that? So come on back and we'll look at that in video 5.